This is 7.6 day 1, the natural base e. We're going to introduce you to the value of e. We did a little bit on a word problem on the previous lesson 7.5. So here's the definition of base e. When we have a base e, we can use our calculator for. What e represents is approximately 2.71. It's kind of like pi, where we say pi is approximately 3.14. So you can write this function as f of x equals e raised to the x power, or f of x is approximately 2.71 raised to the x power. Go ahead and write this definition down. Push pause if you need to. All right, what we're going to do is we're going to go ahead and graph this function. It's a very important function for us to know how to graph. So we have f of x equals e to the x, or same thing as f of x equals 2.71 raised to the x power. So we've set up a xy chart, and we're going to substitute some numbers in for x. So we say, if we substitute 0 in for x, e to the 0. Anything raised to the 0 power is just 1. Now let's substitute 1 in. E raised to the 1. E to the 1 is e, which is approximately 2.71. Then we'll go e to the 2. E to the 2 is the same thing as 2.71 times 2.71, or e squared. And you get approximately 7.3. Now 3. Substitute 3 in for x. That represents e cubed. So that's e raised to the 3rd power, or e times e times e, or 2.71 times 2.71 times 2.71. In your calculator, you would get approximately 20.0. Now let's talk about the two negative numbers here. E to the negative 1. Remember, that is the same thing as 1 over e to the 1. So 1 over 2.71 is a very small number. It's approximately 0.3. And then e to the negative 2 is the same thing as 1 over e squared. 1 divided by e squared is even a smaller number, 0.13. So if we graph this over to the right, first order pair is over 0, up 1. Next order pair is over 1, up 2.71. The next one is over 2, up 7.3. And then over 3, we are off the charts. And then if we go to the left, negative 1, up a very small amount, negative 2, up a very small amount. What happens to the graph looks like this. This is the parent function for e to the x. It has a domain of all real numbers, so negative infinity to infinity. It has a range of y greater than 0, and it has an asymptote at y equals 0. And then this is the critical point, over 0, up 1. Now let's go ahead and graph with a transformation. So we have f of x equals e to the x, and then if you remember, what happens when you add 3 to the end of the function? What it does is it moves every ordered pair up 3 units. So if we go back to this previous slide, if we just focus on these 3 ordered pairs right here, 0, 1, and 2. One order pair is 0, 1, next order pair is 1, 2.7, and then 2, 7.3. If we shift each of those blue order pairs up 3 units, where would we be? So I'm just going to graph the parent function first for the f of x equals e to the x. So from the previous slide, over 0, up 1, over 1, up 2.71, over 2, up around 7 here. So here is my parent function. If I take those 3 ordered pairs and I shift them up directly 3 units, Here's my critical point now. And then that one's shifting up 3, and then up 3. Now where will my asymptote be? Before, my asymptote was right along here, my parent function, at y equals 0. Now my asymptote is going to be 3 units up, at y equals 3. So our domain for this problem, again, is still the same, all real numbers. Our range is now going to be y greater than 3 above that asymptote, and the asymptote is at y equals 3. So the graph has to be above that horizontal line. The next thing is we want to evaluate the function f of x equals e to the x. So with our calculator, I'd say you don't need to write these down. Just practice it. F of 1, which represents e to the 1 power. What is e to the 1 power with your calculator? Make sure you're able to do that. That should be approximately 2.71, and then the decimal does go on. Substitute 2 into the function. So that's now e squared. Make sure you know how to use that with your calculator. That's evaluated the function. All right, now we're going to move on to what we call the natural base e log form. There's 2 ways you can write the inverse function for an exponential. Remember, the exponential that we introduced to you is f of x, e to the x. Its inverse can be written as log base e, notice the base is e, or you can also write it like this, f of x equals ln of x. This again is the inverse of the graph f of x equals e to the x. Go ahead and push pause if you need more time. Now let's go ahead and graph the 2 functions together on one plane. Well, we've done the first graph in the blue already. So remember, this ordered pair is over 0, up 1, over 1, up 2.71, over 2, up 7.3, and then these are pretty small numbers, 0.3 and 0.1. And then this was around 20. So if we graph this in the blue, over 0, up 1, over 1, up 2.71, and then around 7. Okay. So there it is in the blue. If we were to graph its inverse, the notation can be written both ways. When you graph its inverse, you flip-flop these ordered pairs right here. So the first ordered pair would be, instead of 0, 1, it would be 1, 0. So right here. Then the next ordered pair, when you interchange it, it'll be, instead of 1, 2.71, it'll be over 2.7, up 1. So over 2.7, up 1. Then the next ordered pair, as we interchange it, will be 7.3, and then over, up 2. So over 7.3, and then up 2. Now if we graph these 2 and interchange them, we get 0.3, negative 1, and 0.1, negative 2. So over just a very small amount, down 1, and then over even a smaller amount, down 2. And here's what the graph will look like. And it has a domain of numbers greater than 0. It has a range of all real numbers. And now it has a vertical asymptote at x equals 0. So here's what the asymptote would look like, right along here. And that's how you graph the inverse function.